Guys joined. Anyone joined? Let me know if you joined. Let me refresh it. Yeah, okay, so we have already started the live, and today is SQL 11. We're gonna talk about table modification, data manipulation. So it will be very quick thing, but before that, we will have very brief about the constraint that we learned in yesterday's uh, in day before yesterday's live session, that is day 11 10. You could you open this as well, just in case somebody join and they ask for the question, I can simply use my there. So is the account here. Switch the account. Mhm. Oh, the account right again. Here, go for coin. Yeah, so I got this one. So if somebody joined, no, no, this is not the one I'm looking for. Live. Yeah. So I just joined. This is the one. So if somebody joined, I can simply use this for a reference and quickly answer the question, and we won't be messing up anything. Okay. So I thought we did. Yeah. Let's quickly go to our. So when you come into, let me check if it is. Watch. Hello. Yeah. So it does come properly. So now when we will start with a recap as per the post, so we will go to the GitHub because this is where we are maintaining our resources. This is where we are maintaining what we learned, and it's a bit more uh, structure compared with other things. So I will quickly wrap this one. So constraint, I will be very quick with the thing. So what is constraint? So what happened when you try to create a space inside your schema? So that space is table where you will gonna put every information in the slots, right? So what kind of information you are gonna put it? It totally depend on one kind of information or detail you gonna retrieve from entity, right? So suppose an entity of a student coming, he was like my name, my age, my student ID, and my university ID. He gave the four details about the entity. We accept it. But do you think I can accept a text or a string in his ID? No. Can I accept a numeric value as an ID? No. Can I accept a numerical value in his name? No. That means there should be a certain rule and regulation I need to implement on my structure so that whatever the data comes, it will only be allowed to sit or store when it bypass all the layers of the rules. So these rules ensure that data that sit in this one is compiled and compliance with the structure and what kind of a data we want to hold so that future operation become easier, right? Suppose you allowed any kind of a data and somebody inserted integer into the name, and when you started counting and you realize, oh my God, distinct name is like 12315. Does that make sense in real life? No. What we are trying to do, we are trying to replicate the real world scenario into digital world. And in the real world, there are certain things that follows by default or it is unwritten rule, and that rule we have to write in our digital world, and that's why the constraint comes. So constraint is nothing but the rule that apply on the data we are trying to store, manipulate, and organize. Ensure that data integrity. When say data integrity means it compile, it actually replicate the real world data, or it actually have the proper uh, it follow the proper rule and regulation so that it does resemble that real world data and we are able to do all the operation on and over. Okay, the basic understanding. So data type, so here data type alone isn't enough. So data type itself is the first constraint. Because when you allow, or when you create one slot or column or the detail what you want to store for an entity, you ask them that this specific type of data nature is allowed into one, like integer, string, numeric, and etc. This is the rule number one itself, a very primitive rule, or it is first constraint itself. Okay. So if a user attempt to store data that violates a constraint, Postgres raise an error immediately. So remember, if you have a constraint and it doesn't follow, it will raise an error. That means there is a problem with the data that you are trying to either insert or manipulate. The second type of constraint is check constraint. So what happened now? You are clear with the nature of the data that I'm going to receive this one. There is always a possibility that you want to check more than that. For example, you are creating a list of voters, right? So in the voter, what is essential? It should not be a minor. That means the age should be greater than 18. It can go to infinity, but you need to check the date should be greater than 18. So what? First one is data type is int for the age. Very we are good. But if somebody come with the age of 0, 2, 3, 4, negative 100, do you think it's acceptable? No. That is you need to check the value for that entity when we insert it. Each detail should be always greater than 18, right? So this is the check constant that you can use it here. Okay. And you can apply the multiple checks also. So first one is you can simply check you apply this in the structure you like column name, column data type as a first constraint, then check, and in the brackets is like a function. You put the condition. Okay, so check act as a functional constraint. Okay, don't confuse the thing. Second one is here. You can create rather than writing alongside with the name, you can create a two layer of data structure. First one is where you define the column data type or the detail and detailed data type of the table, and then you can create comma like this as a comma and then column. How we are defining column and column data type. Similarly, you can start writing all the constraint. So it's simply like two layer of table that you can define. I think I usually prefer this one because it is more visuals to the eye. Okay, and you can combine this together, so it's not a big deal. But remember, this is a constraint, so you can use because see, if it's a constraint, that means it must have a syntax to define it, right? So the syntax is constraint keyword, then the constraint name. So constraint name is nothing but the reference to the constraint that you are trying to implement. So whenever you will use this constraint name, it will automatically fetch this condition. And then you can simply put the condition. You can simply put in different condition and you can combine them with the end like this one. Like discount should be greater than zero and the price should be greater than discount. Simple. So then now check and null together. So remember when you use this condition like true. So here the thing is very important. I think as a junior developer, a lot of people make mistake. Check allow a data in two conditions. First one is when the expression return true or it return null. It will fail only in the condition when the function return false. So remember this is the first thing. It will fail, it will drop or it will raise an error when the value or the detail of the entity returns a false for a check condition. So if it is so apart from this one, it will pass. So it will pass for true, it will pass for null because null is not false. Null means unknown and it will allow it. Uh, you always heard that word, right? Benefit of doubt. So if it's null or something, it will do the benefit of doubt and allow it. So it strictly follow the rule that if it's a false, then only it will raise a condition that this statement is not it is not following the rule, and that's why they are raising it as a null. So not null constraint. So not null is like when some entity come and he is like, okay, for this table I am giving my detail one by one. And for one of the value like address, right now I don't have an address, so put it empty right now. So missing value, empty value, it void. But sometime it happen because by default every column is null default. That means if they don't provide it, null will automatically set. Basically, it means missing value or is empty value, right? So that's by default. But in case there's few details that we need to have from the entities. For example, student ID for student table. It has to be there. It cannot be empty. So we will put not null constraint. So not null is like when we need to enforce entity to provide a data or detail about his characteristic when he try to insert the data into the database. So this enforcement is can be done using not null constraint. And now again, not null is a constraint, so you can define it constraint, constraint name, and then not null. Perfect. But problem is like not null, null and not null is very simple. They understand it, so we don't do this way because then you need to create so many constraint name. And since the Postgres SQL Server like Postgres take care it by default, like they create the constraint name within the system, so you don't have to do it specifically. Okay, now this is very important. Like you be like that. Why not I put not null in the check condition? Is the same, right? But the thing is, Postgres already optimized not null as a constant itself. If you put in the check what you are doing one thing, but before you do this one thing, you are doing another thing on top of it. So you are increasing number of operation for the same thing that first operation is doing. So basically, you are increasing the redundancy of work. You are increasing the time and resources on the same work by adding additional work that is not even required. So if somebody asks you why not simply like put the not null inside the check condition, so just say it is not optimized and it will increase the operation overhead and overall overall you are just reducing the efficiency of the work. What is unique? So unique is really important customer. So sometime what happen you need to take a value from each entity or the detail from each entity and ensure that it is unique to that entity. Okay. And remember I told you unique value, right? And remember I told you that null in itself doesn't hold a value because it's empty, right? That means a column can be considered as unique if it satisfy either of the case. Either is null or it has a unique value or it have one of its kind of value, right? Because null is empty, it doesn't have any value, so how are you going to compare with some other one? Uniqueness, what it does mean, unique means that are recorded, because I think here it work in a negative scenario that it will drop a value if there is another record with the same value. But does null have any value? Answer is no. That is why if you have multiple nulls for a unique column, it will allow because it is empty value or unknown, and you cannot compare unknown with something. So that means if you can't compare it, you can never get a true value like these two values are matching. That means it failed uniqueness. So that's the thing. So if you want to understand unique is like for every record, it will check the remaining records or the remaining details of the entities. If the value matches and return true, that means it's not a unique value, it will falsify. But now if you match all the value is null, that means it's a unique value. Second, if it's a null, if you compare with everything, it will return null value because when null is compared with the other thing, it's become unknown. When you compare unknown with something, it become unknown. So does unknown is true? No, it's unknown. That means it bypass or it passes that statement that a record is not a unique if its value is available in other entities of the same table. That means unique is either it's a null value or it is one of its kind or the value is not repeated again. So this is unique. Okay. And for the unique, you can define on a single column or you can define on multiple column like combination. So that's it. But the thing is, if I have to identify an individual record in a table uniquely, I cannot use unique because if 10 out of 10 record, 8 have a distinct value, right? But 2 records, 9 and 10 have the null values, unknown values. Can I identify those two? Answer is completely no. That means I need to upgrade my unique into something that enable me to identify each record individually. Why? So that I can access any record at given point of time individually. And that's why primary key concept came in, which means a column or group of columns or any records or the detail, a combination of details of entities in a table will be unique of itself. Second, it is not null. So that null situation is removed. So 9 and 10 record will remove. So 1 to 8 have unique value and you can identify any of them at given point of time. So primary key is nothing but unique plus not. And it is like we use unique as a constraint, and you can simply use primary key as a constraint. Okay. So primary key this one, and since it's a constraint, you can write constraint name primary key, and then whatever the column you want to use as a primary key. So this is the one. So remember, one table, one primary key. One table can have multiple unique constraint. And when you create a unique table and primary key, because they are having a unique ID to identify individual, right? That means you can create an index on it to increase the efficiency to search the records. And that index is B tree, like a B tree index. Now we will talk about the foreign key. Now, I told you in the previous example of university and student, they are two different tables. But if you look at the student, a student cannot exist without university in the picture, right? You cannot be a student if you can't enroll in the university. That means if a student have university ID, this ID should exist there, right? That's the basic of it. So this called referential integrity, where you need to ensure a particular detail of an entity in this table should exist exist here. Okay. If it doesn't exist, that means break that referential integrity. And Postgres mainly work on that negative things, right? So if the value is present here and it's available here, right? If it doesn't available here, that means it failed. But what about the null? Again, availability and non-availability, how we do? So what I say referential integrity is if a value or the detail of an entity in this table but match with every record and it gives me false, that means it break the referential integrity. Not talk about two condition. Now I check. It doesn't match anything. That means it's false. That means this is breaking the referential integrity and it will raise an issue that this record reference is not available here, and it break the referential integrity condition that every student belong to a university. So this record have, and we cannot digest this or insert it. Second condition, the record came, try to enter it, it will start checking. It's available. No. Yes, it matched. That means the student belonged to university number 5. So it's a legit record. You will insert it to the student table. Third condition. Data came, but the university ID is empty unknown. Empty unknown, unknown. This two record unknown and university ID two unknown. When we compare this unknown university ID of a student with the university ID 3, answer is unknown. What answer you're getting at the end? Unknown. But what I said, it break referential integrity when you compare with all the record and it gives false. It gives false. Is it false? No, it's unknown. So that means it's past the logic of negative or dropout. And that's how it is allowed in the existence. So two of the cases again same as unique. Like either this value exit here or it is a null that it follow referential integrity. And the last one that's I genuinely like is exclusion constraint. Exclusion constraint. And remember, unique constraint is a specific case of exclusion constraint where you put condition or the unique condition in more than one way. So an exclusion constraint ensure that for any two rows, at least one specific comparison between them return false or null, preventing overlap or conflicting that unique alone can't handle. Okay, I think for this one I already did here. Here I kept this one. I genuinely like this one. Exclusion constraint are more powerful generalization of unique constraint. It instead of just checking quality equality that they allow you to define custom condition. It allow you custom condition using operators and index method. So it allow you to do all two things. So unique is no two rows can have the same value. It's the same. Is a specific case of exclusion constraint. No two row can set a no to row can satisfy a custom condition overlapping. So we are using more than here we are checking just values. We are checking here values plus it always provide the overlapping range or same circle etc. So it provide more than that. So operate and your constraints. So for example, this is the table and you write here this one. So if you see here the exclude using just so we are using index. Okay. Now room ID with so it's a column name with equals to so here you're checking the name same room. So for the same room, what it says booking with ampersand means overlapping date. So at given point of time, for it says here these two combination of room ID and the range of booking should not match. When I say ampersand, it means here it should not overlap. That means if the date is between these two range, this date one, this date two for a room one, for the room two, the for room one for another customer, it can be here, it can be here, it can be here, but it cannot be this, it cannot be this, it cannot be this, it cannot be this. Overlapping should not be happening for the same room, and that's we do it using the uh custom unique constraint here. Okay, now if we take another example, it created a schedules where employee ID shift and shift is timestamp range, and then we exclude using just. So just is nothing but your index. So employee ID with equal to means same ID. Operator is like equal, both have the same values, right? When shift with ampersand again, it should not ampersand means like their timestamp should not overlap with one another. Okay. Yeah. Yeah. So I think it's really cool. Here, for example, see here, create table. They have written here properly, but it's same as that, but they are using date range here. So create extension if not exist it just okay. We create one extension and then we started writing create bookings where room ID is integer and booking is date range, not timestamp range but date range. Now I am using exclude custom custom unique constraint, and it goes with using just as the index, just as an index. Okay, where I need to check for this room ID with equals means if room ID is same, when booking of these two range should not overlap with one another. I think I will include this in my this one so that you guys have fun. Okay, that's it. Recap is done for day one. We have completed the recap for what? For constraints. Now we will start with table modification. How we can modify the table. So you know that we use the official site PG exercise. We will go here. We will go with data definition and we will start with table modification. So table modification is like, so what happened when you create a table? Not gonna stay static. It's not gonna stay same throughout your development cycle, throughout your time, throughout your period. So there's a time when you need to change it. For example, when you create a table and you realize you made a mistake, and or required a requirement of the application change, you can drop that table and create it again. But this is not a convenient option if the table is already filled with data or if the table is referenced by other database object, for instance a foreign key constraint. Therefore the Postgres provide a family of command to make modification to the existing table. That means you can change the structure of the same table with the data without 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 hindering the other dependency on this table, or without even touching the data that was already residing into it. That's why table modification become really important, because see, today you created one table and you realize you made a mistake, you can change it using this. This is not the only case. There is a time when the business requirement change, or they want to add more to increase the features. So you cannot create table again and again and then you change the dependency again. and then you started working all over again because the data dependency is high and production data you cannot touch easily because the data is already flowing, everything is good, you cannot go and change it like this because then you have to do thorough testing of this whole system again, and this is not the right way. You have to change in a modular way, so something even if go wrong you can retrieve the version back. So what are the modification you can do? So you can add a column. It is always good. People need always add. For example, if there is a new feature is needed, you can simply create a new table, a new column in that table. You can add column to that table and insert the value based on the requirement. So you are not touching the table at all. You are simply modifying. It's same as like you already constructed a house, and now you are slowly and steadily building more feature into it, like more rooms, you can bathroom on upper floor, then second floor, third floor. So you keep on changing. Remove column. Sometimes you need to remove the column because it is not required. It is making your table heavy or has a sensitive data that you cannot show to anyone, and by mistake, no, not by mistake, but initial architecture flow diagram or architecture requirement, you did cap that. So that's the one thing. So now you don't need it, you remove that one. You can add constraint. I told you that initially you go with not null, but as time progresses you get more data, you understand this one and keep on changing. For example, in live date, when we were adding null, we were deleting null based on the on delete cascade, on delete restrict, right? On this on delete set null, on delete set default. We were changing it constantly based on our requirement. Now change the default value. That's also pretty much used. Change column data type. Yes. Rename column and rename table. This too something you might use often. Rename column, not rename table, but yes. So rename table, I think better you create a table and then put all the record into that table. In this way, with the origin, for example, what I want to say, let me quickly show you. So there's a table say A, and you simply change it to table A dash. Okay. So at given point of time, you suppose at time when you started, suppose 10 o'clock, and time 10:05, like after 5 minutes. Okay, there only exists this A dash, right? But the but sometime it happened that you still need this table as well, because after a dash you do the modification and you realize the modification you done is not right and you lost the original table. Sometimes what people does, they create a and then simply replicate this a and make it a dash, make the changes, and when everything is done like productionization or everything is done, this is passed all the test scenarios, it passed from the client side, then we drop this table. At given point of time you can simply switch it back, because to switch back to the snapshot, the problem is like people do say why we do this one, why not simply do this one, and if something happen we can roll back everything, right? But the development goes for days, it doesn't go for hours or minute, it goes for days, because if something change come, you usually take 3 to 4 days, that include testing and the stuff. And after 5 or 6 days, you realize, okay, I need to change it back. But during this 5 and 6 days, you are not the only one who is making the changes. And if somebody is changed based on this one, and you now going back here again, it's a big no-no for that guy as well. So to make sure that this original stays, and you create this one new, and then inform collectively to other people who are using this one that we have started using this new table with this new feature. You have to redirect to this table going forward. We're gonna drop it because that's already productionized. Other people don't feel pressured, and they will be like, okay, now we can do it slowly and gradually. Okay, so now we will start with this one slowly and gradually. Okay, so what we are doing, we are not just like we're just not reading it, we're gonna implement this everything, and it's very simple thing. So what we are doing, we create a schema university, then we create a university and this table. Why this color? So I'm going to create only one schema campaign. I'm going for student table. and I'm going for student detail. Okay, I love to write detail. It's been years I use this. Or I think I should go for info detail. I think student detail make more sense to me than this one. So now I will create a table with the keyword create table, and then table name is student detail. And then I will define how my structure gonna look like, what kind of cabinet I'm trying to build. Okay. So if entity comes for student detail, what kind of detail? If an entity student came, what kind of a detail I want from him? Firstly, I want his stud. Since it's already student, so I will simply use ID as integer, and I just want to make it primary key. But the thing is, like, since I'm an administrator, I can give it the ID myself. So I will simply generate that ID for him. So I can write it generated always as identity. Okay, it will automatically generate, but there are few people who can hijack this one and is started using one thing that can bypass this as well. And because as always, like it automatically it doesn't take user precedence, it's always take this precedence, so it will automatically have primary key. To make sure that you know this is a primary key, you can simply write some kind of a marker primary key. Even if you don't write it, is still fine. But this is good to keep it primary key so that in any case if somebody use a, a bypass method, there is one method that can still get you a value inside this one, like give precedence of user value than the system value. Then name plus text. Again, I want it not okay. I don't want it. ID is the name is then I need age. Then again is integer, and I want to make a check on this one. Check. I can create two different one. I can create in this one, but this is very small, so I've been keeping alongside with the column, so it's easy to understand and easy to track. And I want to check that at given point of time, the age should be always greater than equals to 18. And now since is a constraint, I can use this constraint name age check, and then constraint is check and the condition. I can do this as well, right? Name age. I think this is enough for time being. If I run it and then select start from my schema that I'm going to constrain. So I need a schema. See, I told you if you don't define a schema, it will automatically go to the by default schema for a database that is public. But I don't want it because I want to keep it in a separate space, a separate floor that is a schema student. So now I will access a student floor or student schema dot stud underscore detail. So drop. Oh, okay, so there's a mistake. See, drop table if exists. Drop if so you need to remove this. Drop schema like create table drop schema should be together. It's like a combo. So now you see everything is done and this structure is created because I haven't inserted the value. Right now, quickly insert the values. Insert values. So insert into, see again the combo of two, like create table, drop table, insert into. So these are like combo. So insert into table. So in a floor or the schema, student, I need to access student detail. And now I need to fill this with this value. So values is like a reference. So this is the first detail about the first entity. Okay, so this tuple or this bracket. So what I gonna put is your ID. It will by default come. So I will put default value. So it will default. So it will automatically put that ID. So I don't need to do anything. Name is suppose Nathan, and age is right now I'm 20 years young guy. Then there's one more guy with me, default Robert, and he is 25. 3435, and I will run it. See, those two came, so I'm good. Now we will start using DML, DDL, data definition language. So first we're gonna do DML that modify table. So first one we gonna do in is add column, right? So what happened? Like I saw there's ID, there's a name, there's a age. What was missing is a university ID because as a student you need to have one university ID, right? So how we can do it? So how the combo of two, right? Create table, drop table, insert into. There's one to add this one to change the modification or to change the structure of this one. We use alter, alter table, right? Create table, drop table, alter table, alter table. Which table you need to give the name, right? And then you need to add this modification that is add column. Again, combo of two. Add column. Then you put the description. Then you put the text. Okay, you add the column. So now you have to add the column. So basically what you are doing, you are defining that column or column name, and then you could put the constraint as well. So let's do this one. Okay, see here, alter table product, add column description, text, and check. So it's same as what you are doing, how we did it here. We doing separately, and then we are trying to tell that there's already a structure there. Simply add a comma this one and drop and recreate. But we are not dropping, we simply adding this one. So we are not touching the existing structure, we are simply adding a column. So alter table combo of two. The table name we are going to change is. So first one we need to go to floor, that is a schema, that is student. And then we need to go to that particular shelf that we have created. And that shelf is the cabinet is, or the shelf or the cabinet is your or room is a student detail. Now what I want to change in this big cabinet is I want to add one more column of cabinets or one more column, that is add column. Now when I say add column, now this one is done. What now I have to follow, you since you are telling them you need to create that one more structure, one more column in that entity that gonna come into it. So you need to define like this, right? You need to give a column name, column data type, and if there is a condition, the column name is uni id, right? And it is integer, and it's a what is a foreign it's a foreign key, but right now I haven't created university, so I'm keeping it simple. So I'm just I don't want it null, it should have a value. I'm closed. Okay, now I will run this thing again. Retrieving data. Let's run this. So uni ID of a relation is student contain null value. See, it is null value. It cannot be null, so time being is new table. I'm keeping it null, right? I said not null, but by default, since we are not providing any value, right? So it has to be. So when I provided the value for all the values into it, then I can add. So, okay, so it should be not null, but right now I haven't given any condition, so I'm keeping it null. The reason for this one is you will understand in a couple of queries. So let's keep it here. Now go for second one. So add column is done. Removing column. Okay. So again, alter table, table name, drop column, and the column description, basically column name. Now the biggest problem is whenever data was in the column disappeared, the table constraint involving the column are dropped too. Okay, so whenever the data was that when whatever data was in the column disappeared, table constraint involving the column are dropped too. However, if the column is referenced by foreign key constraint, again, if you are not putting it as a cascade like dependency, right? I told you by default is always on delete restrict. If there is no corresponding value in the child, it will drop it. But it is, that is a problem. If you have to give him power that once I delete the parent value, all the corresponding child values should be dropped. So you need to add cascade. But here the cascade is not needed. So I'm going to drop the university ID again and we'll recreate it. So drop call alter table again. Table name is type schema of the floor, and then inside this cabinet is detail drop column. You need to drop, right? So drop column, and column name is uni underscore id. And the thing is there is no dependency on this one, so I'm not putting it. So by default it's gonna be uh restrict description. So let cascade okay, is delete now. Restrict. Okay. So once it's dropped, cascade is fine. Right. So make sure at times you don't use cascade so you understand if it's dropping properly or not. Yeah, cascade is like if there is a dependency on this one, it will get the value. So now I'm adding the column back because that I need. Drop is done, then adding a constraint, right? So I told you that here is a null, but at given point of time, university ID cannot be null as per our understanding. That means firstly we need to replace this value with some integer value that's some id. Say is 0. 0 means right now it was not assigned to any value. So first we will just change this to a default value. So simply we will write here add constraint, add constraint, add constraint, change column for value. Okay, so we need to add a constraint. So here you can use again alter table name add. So you simply put the same thing is simple as how we constraint define is simply constraint name and then the corresponding constraint, or you can write it constraint then constraint name then the constraint that you want to put and the condition. Okay. So what I can do, I can for unique id, I cannot put it unique id here, but I can do what I can do. I can put one more constraint on our age that it should not be at a given point of time greater than 50 years old. Okay. Suppose what happened, there is a guy who came and for a fun he put the age as 100. Is possible a student of 100-year-old coming to the university? Typically no. And we will make sure and we know that through the brochure that above the age of 50 the students are not allowed or enrollment is not allowed. That means the limit for the age is 50. So add constraint. So let's add one more constraint here. How it is alter table, then table name, then add, and then simply constraint. Okay. So we can write it alter table. Table name is floor student, and then the corresponding group of habitat is student. Detail. I want to add now how I define the constraint. So similarly, you write the constraint, whatever constraint you want to put, and then the corresponding value, how we define it. Or you can simply go with this bigger out constraint name, and then the constraint you put. So you can go either of the way. Like you be like, let me put check, and it's a functional constraint. So age should be always less than equals to 50. So if you know one, if you re- if you learn the proper way of constraint, you just have to add a simple now. Say it's done. Or I can write add now more proper is constraint and constraint name check age. But the problem is like you age check you already write like so age check underscore 18 and underscore 50. You can write like this. So you understand like what you're using. It's done. See, same method you know about the constraint, you're simply adding the same thing here, like this. See, alter table table name, and then add column, drop column, add column, drop column, then add constraint. Now I think other one should be drop constraint if I'm not wrong. So alter table, add a not null constraint, the same thing. Alter table table name. Why it is not used as add? Okay, if I have to put not null, I think let's do it. Here in the name, I'm not in the name not null, right? Let's remove it. That means I can add a text. I can put an empty value in the name. Okay. Now I need to put that. But sometimes you don't know about the things. You initially thought like the name can be null. Okay, you kept it. Okay, default is null or unknown. Now the business says it's not possible. If entity is coming, is this information a student? It should have a name. You were like, okay, I will add a constraint that it should be not null. How it does alter table? This one, alter column. This one, alter column, alter table, alter column, and set not null. Again, let's try the method of constraint because not null is a constraint, right? So let's do that. Truth. If you can go with the sync, why you have to learn differently? So add not a constraint, right? Alter table, table name student as a schema than the cabinet structure student detail. Add now. Okay, constraint. Constraint. Name, not now. And then not null ID. Okay, I will add. See, that's the one. So if you remember, we we usually keep it not null here, but if you go with that logic of two layer constraint, you want to add the constraint at the table level rather than the column level. You want to create put the constraint at the table level, means separately as a you need to define it like a column wise, right? For not null is like not null and then simply column name. That was your name. Okay. And you put a comma here and you run it. See, done. And what you did here, nothing but you just did the same thing. Alter table, student table name, add not null ID. But I was thinking like, can I add more than that? Like, uh, constraint is not null ID common name. No, I don't think we can do it. Can I? Because the problem is like, because of the comma, it will be another separate entity. Let's see if we can do it. Answer is no. We cannot do it. Not null. Right. Okay, I have one here. Okay, see, this is done, but now let's check the brackets. No, not null has to go individually. Individual. You cannot make it in a group like how we define a unique because we are combining them as a single individual. So constraint has to be applied on the column level, I guess, like on entity level. So you can do it, but the other way is alter column, this set to now. I don't know why I have to use it, which normally not written as table constraint. This should be as alter table, table name, alter column, product set, this one. So I'm not going with this one. When I know it's simpler like this, add, because it's a constraint, right? I can simply use add. Don't go with that. Fifth one is removing constraint. See, add column, then we drop the column, then add constraint. Now we will drop the constraint simple. Alter table, table name, drop constraint, and then constraint name. Add constraint, drop constraint. It's very simple though. There's nothing. And alter table, table name, alter column, column name, and then drop not. Okay, because of this, I might let's see if I can go some alternative route. Because I think I will so drop constraints, alter table, table name. So I will go to the floor student, and then I will have that structure cabinet detail drop. And what kind of a constraint I want to drop? I want to drop this one. Drop constraint. That's why the constraint name is very important. You can simply like this. Now that constraint will be dropped, and I won't be able to add any any record with. I can add any record with the age greater than 50. Okay. Now let's drop constraint. Not me. I was thinking if I can put the default value as null, right? This can be one thing. Changing a column default value same as this one. So I think alter table schema student dot start detail. Now this is at the value level, right? So far it was the structure level at the rule level. So add and delete was fine. But now if I have to go at the value level, I think I cannot. What can I do? It at no, no, I think I have to go with all of them. I think it's better not go in this way and go for the change default value. So now you are working on the value level. So alter table table name, alter column, because now you are changing the column level or value level of information, right? Data inside this one. So now you need to change the first you were working on the table level, the structure, like adding column, adding dropping column or adding constraint and dropping the constraint. Now you're working the value it's gonna store. So we will use alter column. That means you are changing the value inside this one. So it's a column level. First was the table level. This is the value level. So alter column set default. I think set default and the value. If set default, set default. I think like this. But which column? Alter column, then column name, then drop not null. Okay. So because ID age no uni ID set default now. Perfect. If I have to drop, I think I can use this one seventh. Uh, drop constraint, not so basically I'm going to the value, right? Alter table, student dot stud underscore detail, alter column, uni underscore id, and is already set. So drop not yeah. Yeah, I think here rather than not null name. Okay. Not null name, and I want to drop it. So why don't I simply use? Okay. Uh, so in this one, all the equals student dot start underscore detail, all the column name. How they are altering the not minimum constraint. All the column name drop all to set not set. I think this is the one had the issues. Drop not allowed. Line number one. Syntax error. Drop uni ID. I'm adding it again. Then I add the constraint that so then drop a constraint. Okay. So add not null to the name. Alter column name set not. Okay, so alright. Okay, so I can do this way, add not null name. I can do this way. But the biggest problem is like I won't have the corresponding drop statement. So even it work, I can't use it. Then this one. So now it's a value level. Constraint. So alter table this one. Alter column name set not default. Alter column name drop not null. Okay. So I did not null and then I drop default value. So I want to add a default value. So alter this one uni ID set. Yep. So if not providing, it automatically set a value of null 5. I know this. And then removing a constraint. Alter column. Drop not null. Okay, so for add not null, drop not null. I'm not considering it as a constraint as a rule, but more of like the constraint on the null value itself. And now drop not null is done. And how, because it's on value level inside the cabinet level, not on the structure level, right? So we are using alter column. So column name then set on top and set default and remove constraint. So adding a constraint is done, removing a constraint is done, changing a default value is done, drop default. So if I have to drop it, so now again ninth, drop of value, alter table student, what is that detail, alter column, and column name unique ID, drop default. Yeah, set default, then default value, drop default value. So this four. So now remember, when I am doing on the table level, that means I am adding a column or deleting a column or adding a constraint or deleting a constraint is on column level. I'm not touching on the values, right? So it should be add column, add constraint, drop constraint. But if it is a value level, like how the value is gonna come and this one, so it's not null or default values and this one, okay? So adding not null, dropping not null, uh, changing changing means like adding, changing default value or dropping a default value. You will simply use alter table name, then alter column because you are changing the value inside a column, right? Not at the table level. So alter column and then column name same, set not null, drop not null, set default values, then drop. This is a big thing. Now changing column data type. Again, data type is funny, the value level thing, right? So you have to use again alter table name, alter column price, then you will alter column name, then you will use like we use set and drop, right? Here we use type, and then we will type the values. Now renaming it. So simple, we will keep it like this. Suppose university, I want to put it as a text. Okay, university ID for timing. We will change it back. So change data type because we want to change the data type. So data type say again we are changing the value, not the structure, right? So alter table row is a student and then cabinet is student detail and alter column is uni underscore ID and we are changing the data type. So here's a type and I want is as text. Let's run it. Done. Text is done. So either I will get a text value or I'm getting a null that is unknown value, but I will retrieve it back again and because I want it. Okay, the problem is alter column, correct integer. Drop cascade to the table notice error. Column university cannot be cast automatically type. So string to this is not easily possible. So I need to use the word this one using. I need to typecast explicitly, right? Unit integer. Integer. I think this is wrong. And using, but I don't know how to use it. So typecasting is needed because when you're sure that every text is should be either null or it should be proper integer. When it's converted, so unique ID cannot be casted automatically to this one. You need to have. Okay, so this is something I need to check how to use this one. Let's a new chat. I don't know what's the timing. How is going to use it? This error cannot present. Okay, so add alter column name. This one type integer using alter column type integer then using this one the one he suggested. And it's a typecasting we use when when we tell him that we know all the values inside this column that is text is either null unknown and the value inside the text is integer value. So when you convert it will give you integer proper integer. So using uni id buildable and integer. Now he understand that okay, that means you are sure I don't have to worry. Like, it will automatically won't does it. You have to tell him specifically. So you can ask why we have to it us self why we need to use using why can't he do it by himself. So great question. Postgre is deliberately cautious. The reason is the converting text is not always safe or obvious. Postgre does not know how you want to conversion. How want the conversion done because there are multiple possible ways. This one. Ah. Oh. Integer to begin. Always safe. And this one is a Losing ambitious. It could silently corrupt or lose the data. Okay. Simplified. How you handle this when converting to integer. So work clean error because it's a okay. I need to again do a typecasting again. So first floor for the float and then integer. Okay. Error. Null if this one or null if is either of them is true, you need to handle coalesce. Coalesce. If it is n slash or this one error, you need to explicitly define a condition like using null if. Okay, if it's a null if If it's a null, if okay, you will put null if it's this one and then integer you are converting. So you are changing the value into null or simply coalesce. I forget you how why we use the coalesce. So using is like when you provide expression thus and so safest approach is when case this one is this one then ID else null. The reject check if the value is purely digit before attempting the cast, giving you control. Oh, so it does check for this one and before running, make sure your data is clean. If it contain any non-numeric string, the typecast field. So select this one. Where this is interesting. I think coalesce I need to remember to what is coalesce? So, null if this one. And or it will coalesce. I think coalesce like whatever whenever you have null you can replace it. What? Just coalesce. Just this is interesting to know. Coalesce return first non-null value from the list of arguments index. So coalesce. It oh return the first non-null value. So coalesce phone this from user. So if it's phone, it will give a value. Email, it will give the contact information. First non-null. So this won't work. It null if so it will convert empty string into null for this column. If this one, it will null. It will null. And if it's a null, it will return zero. Why? Because the first non. Oh my god, this is a good one. This is a good one. So we have changed the data type. What else is left? Good man. Mm, renaming a column and renaming a table. So again, alter table name, rename column name. So let's say university ID, I want to rename it to a proper name. Rename column. Alter table. Floor is student and the cabinet is student detail. And I have to rename column. I think it's always where alter table, all columns or rename column. Yep. Rename column. And what is the column name? Uni underscore ID to university word university ID. See, change it. Now I will change it back. This to this. See, it is university ID. Now, if I have to change the table name, that's more interesting. Rename table. So we work on the structure of table columns, like how and constraint. Then we work on the values of not null default values. Okay, add and drop. Okay. Then we work on renaming column and we are renaming the table. So we are working on pair. And then we also did the data type, change in the data type, alter table name, then the column name and the type, this one. And if we have to define very explicitly, then we will use using. That's pretty cool. That's awesome, awesome. Okay, renaming a table, alter table name. Simple. So alter table student stud detail detail rename to right? Rename that column name, whatever we were using, we will simply rename to student dot detail. And now this won't work. This will throw error because now we have renamed it and it cannot access. So now it's done. We will just do it, and then we'll select the start from the student and dot detail. Uh, so I don't need to use this. What it says. Okay, so when I access this one, I don't need to define the dot. It will automatically change it. Let's check it. So here I'm going to database student and the schema, and I will go into the student schema. Which database I'm using? University. No, yeah. Inside the university, I have a floor for student, and here the table that was initially the detail now change to detail. Now we will put it back. All the people. With this, I already got access to this one, so I don't need to define the floor again. Student is let's go detail and then rename to stud deal. Uh, relation student detail. Oh yeah, it should be here. Yep, we got it back. So today we learn about changing the table modification at the column and constraint level. There's add column, drop column, add constraint, drop constraint, right? Then at the value level, we work on the default and not null. So alter table, table name, alter column, column name, and then we were doing putting like uh set not null or drop not null or set default value drop default. Was that's the one. Then once that is done, there is three cases here. One more is data type. When we need to change the data type, again is a value base. So alter table, table name, alter table, table, alter column, column name, and then data type we are changing will be simple like type, whatever the integer is. If it's explicit, when there can be multiple cases, you need to define using an expression using this one. So what you are trying to do, you are trying to give him expression how you need to convert the each values from one data type to another data type in case the explicit conversion is required. Then the rename of the now now is renaming the column or renaming the table. So alter table table name or rename column old column name to new column name. For the table, it's like alter table table name rename to the new name. That's it. I will keep it with me. Can I save it? SQL table modification. I did thought like I could be able to cover the uh, this one, not the schema basic define. Uh, changing column default, changing data type. Yep, this is done. I thought I would be able to go into data manipulation because this was simple, but I think we need one more day. because I have to rush to my work. I can't delay. So guys, that's it for today. I hope you enjoy it. I will upload the video in channel, and future I will make more interesting videos.